I want to add just a few things to your notes. So when we're looking at these histograms for continuous numerical data, you're using them when you have one variable, continuous numerical data, and you're trying to display the data distribution. What you can look for in a histogram would be the center or the typical value, the amount of variability. Those two things we'll be talking about in Chapter 3. The general shape, and we'll be talking about that soon, and then the number and location of the peaks, and then any gaps or outliers. Because we'll mostly be doing technology to actually create these histograms, it's really important that we learn what to look for and how to describe these. So if we look at another example, looking at the influence of school time and the sleep patterns of children and adolescents, they were looking at these school-age children who had either a morning start or an afternoon start. And so they wanted to see what the sleep deficit would be, which was defined as the difference in sleep duration on weekends and the sleep duration on nights with school the next day. So they measured these in hours. So for example, if a student usually had 9 hours a night on the weekends and had 2 hours a night on the weeknights, they would have a sleep deficit of 2. A student with a negative sleep deficit, so something like -3, that would mean that they slept 3 hours longer on weeknights than they did on weekends. So we could have some positive and some negative values. Here we look at the frequencies, and because this was such a large data set, using the frequency would not be appropriate for your histogram. You would want to look at the relative frequency here simply because of how many items you had in each category. So you would look and you would see a histogram that ended up looking like this. Now it does appear that most of the students do have a positive sleep deficit, so they were getting less sleep on school nights. Most of the values seem to be between 0 and 4, and we don't have any gaps or outliers here. So those would be some of the things that you would use to describe histograms. Now we can also use histograms to compare groups. And so whenever you are trying to actually make some comparisons, then you'll need to create an appropriate histogram. So if we split that data set into morning start and afternoon start with the same sleep deficit intervals, we can split the data up and look to see if there was a difference based on when school was starting. So here we have side-by-side histograms with the same scales, and we can make a nice comparison. When you're using technology, sometimes you have to do a little work in order to get the scales the same. So just be cautious when you are making comparisons on histograms if the scales don't match up. But we notice here that the afternoon start group had a little bit more there in the middle than the morning start did, but they had a similar spread. So what are some of these shapes that we need to talk about with histograms? Well, one of the most recognizable thing of a histogram is how many peaks it has. So these peaks would be considered the mode. So if you remember from maybe elementary school or middle school, the mode was the value that occurred the most frequently in a data set. Well, in a histogram, the mode is going to be the interval that occurs the most frequent. Now, you might have more of a relative mode, so you could have a peak in one area, a peak in another area, and both of those would be considered modes. So it's not quite as strict as the definition that you used when you were in a younger grade. So we see things like this where we could have a unimodal where it just kind of peaks there once, not necessarily in the middle, but you just see one peak. A bimodal is where you have two peaks. This is going to happen whenever your distribution has two groups in it that would have some significant difference. For example, if you were looking at the maximum weight that somebody could bench press, your females would peak in one area and your males would peak in another area. Not that there aren't some very strong women and some not as strong men, because there will be, but you'll see the peak of the two groups in a combined data set. And then multimodal is where you have a lot of peaks. Those are a little bit harder to find in data sets that we'll be looking at, but they do occur. Now, we talk about shape. with the peaks, but we can also talk about the symmetry. Symmetry is where if you drew a vertical line, both sides of that line would look approximately the same. Now, we're in the real world. It's rarely going to be perfect, but as long as it's close to the same on both sides, we would call this symmetric. But when we don't have symmetric, then we're going to be able to describe this as positive skew or negative skew. Any histogram that's not symmetric is called skewed. So how do you know if it's positive or negative? Well, a positive skew is when the upper tail is going to be much longer than the lower tail. So it's right skewed, the tail is stretching there towards the right. You have a few really large values. A negative skew or left skew is where the tail stretches to the left. You have a couple really low values, but most of the values are not small. So these look something like this. And then I have to do a quick introduction to my cats. And you guys couldn't see, but one of them has been sitting in my lap this whole time. But this is Chester and Chloe. They're my two little babies. And they were sitting upstairs one day like this. And it made me think this is exactly like what I do with histograms. You have the body of the graph, but then the tail is on one side or the other. So Chester is right skewed or positive skew because his tail is sitting there on the right. His body's on the left, but the tail is on the right. Chloe's left skewed, her tail's there on the left, and so that would be a negative skew or a left skew. So when you're trying to decide which skew you have, just think, where's the tail? We'll be speaking specifically about one special shape, the normal curve, and this one is symmetric and bell-shaped, and this will be very important to us later this chapter.